When we introduced the logarithm, we said it reversed the effect of an exponential function. This means the logarithm allows us to find solutions to exponential equations. These are solutions that we could not otherwise find. To proceed, we first need to be aware of a basic property of logarithms. The property is as follows: log of a to the t equals t times log of a. This means if we do not want the exponent t inside a logarithm, we are allowed to bring it outside of the logarithm as a factor in a multiplication problem. This property may look a little familiar to you. That's because it comes from the property of exponents that says 10 to the a to the t power is equal to 10 to the a times t. Since logarithmic functions can be defined to be the inverse of exponential functions, it's not surprising that logarithms have a similar yet unique property involving exponents and multiplication. Please keep in mind, when using this property, you may substitute any quantity you want in for a and t, but otherwise this property must be used exactly as written. Any small deviation will give you an error in your computation. Be especially careful not to use this property when you have something of the form log of a to the t. Notice this is different from above because there's a quantity multiplied by a to the t. If you attempt to use this property and write that this equals t times log of a, your solution will be incorrect. Example 7. Suppose we have a population that is initially 500 and grows at a rate of 0.5% per month. How long will it take for the population to reach 800? Notice that this example describes a relationship between two variables, population and time. Since population depends on time, population is the dependent variable and time is the independent variable. Also, note that the growth rate is 0.5% per month. It's a constant percentage increase. That means population is an exponential function of time. Let's find the formula for this exponential function and use it to solve this problem. Recall, the formula for an exponential function takes on the form dependent variable equals initial value times base to the t power. Because this is exponential growth, our base equals 1 plus r, where r is the percentage increase each month. Our initial value is 500, and r, our percentage increase as a decimal, is 0.005. Don't forget, since the percentage increase is given as a percent, to make it into a decimal, we need to divide by 100 or move the decimal point 2 places to the left. Our formula for population as an exponential function of time is population after t months equals 500 times 1 plus 0.005 to the t power. Often, it's our independent variable that is known and we are solving for our dependent variable. This time, however, our problem asks how long will it take for the population to reach 800. So our dependent variable is known, and we are trying to solve for our independent variable. We begin by trying to isolate the t. Since 500 is being multiplied by this quantity, let's get rid of 500 by dividing both sides by 500. 800 divided by 500 is 1.6. On the right, 500 simply cancels out, and we're left with 1.005 to the t. Again, we wish to isolate t, but since t is stuck in the exponent, it is unclear how we might continue. This is where we need the property of logarithms. Remember, we could do anything to an equation as long as we do the same thing to both sides. If we take the log of both sides, the right side will look very much like log of a to the t. That means we could use the property of logarithms to bring this t out and in front of the logarithm. Let's do it. We get log of 1.6 equals log of 1.005 to the t power. Now my right side of the equation is of the form log of a to the t, so I can use this property of logarithms and bring that t outside of the logarithm. After using the property of logarithms, we get log of 1.6 equals t times log of 1.005. This might look complicated, but remember, log of 1.6 is just a number. We could type it into our calculator to find out what number it is. Similarly, log of 1.005 is just a number. So this equation is similar to the equation 10 equals 5t. To solve 10 equals 5t, we would divide both sides by 5. So to solve log of 1.6 equals t times log of 1.005, we will divide both sides by the number log of 1.005. On the right, the log of 1.005s cancel out, and we're left with just t. To compute the quantity on the left, we will need to use our calculator. When we do so, let's make sure our parentheses are in the correct places. We input log parentheses 1.6 end parentheses, divide sign, log parentheses 1.005 end parentheses. We get that t is approximately 94.2 months. That is, it will take 94.2 months for the population that started at 500 to get to 800.